But first I have a question for you guys. And this is something I've always wondered myself. All right, so we look at this. You see the difference between the two? What's the difference? One's brighter. So this is called fluorescent orange, right? You ever heard of that? You ever wonder why this is so much brighter than that? I don't know. I wonder about these things.
Fluorescent.
Yes, that's a fluorescent. But I mean, exactly why? And I'm going to explain that to you right now. Why is this so much brighter than that? And it has to do with actual fluorescence. So I'm going to explain that to you. And this has to do with why I became a chemist. And I was curious ever since I was about 8 years old. I was wondering. I mean, it's just striking to your eye. It's really, really bright. So I'm going to explain to you guys why this is so bright and a couple other things, and it's going to lead into the rest of my talk here.
And you're okay if we take pictures?
So what fluorescence? Okay, so I'm not going to lie. I'm going to give you about 3 slides of real chemistry. So if you bear through that, you're going to be able to understand a lot of different things. So fluorescence is, by definition, it means I'm absorbing one type of light and I'm emitting a different type of light. And that's really all it is. I'm keeping it very, very simple. And really what we're going to be focusing on is molecules. Okay, this is where the chemistry comes in right there. Molecules that absorb ultraviolet light. So we're going to talk to you a little bit about ultraviolet light. And emit blue light, maybe some different other colors. But they're absorbing ultraviolet light and they're emitting blue light. So you can see I've got my little black lights here. These guys emit ultraviolet light. So we're going to be turning out the lights here in a little bit. So just a little fun with that. So I know you guys probably don't understand these structures, but overall, what I want to tell you is this piece of orange paper is so bright because it contains molecules in there that fluoresce. And so this is the idea where chemistry comes in, is we understand these molecules. I know how to make these molecules. The molecules in these commercial products I'm going to show you, some chemists made them. So this is where chemistry shows up inside of the real world. So the orange paper contains molecules that fluoresce, and these are 2 common ones we're going to see where these show up in quite a few different places. But really, so I say that they fluoresce, but it really doesn't explain to me how does it actually appear so bright. And it has to do with the idea of ultraviolet light. So I don't know if how much you guys understand about
You've seen this before, right? At least physical science, yeah.
Well, you guys know about light, right? You should. So this is just a spectrum of typical white light. I go outside. And I think we all know that white light is made up of all the colors of the rainbow. And that's exactly what happens. You go out on a kind of a misty morning, you see a rainbow. What this rainbow is doing is taking the light and diffracting it. And then you can see these different colors inside of it. So white light is actually very complex. There's all these different colors in there. But what I want to talk about is the fact that inside of white light, there's this little piece right over here of ultraviolet light. So inside of white light, there is some ultraviolet light inside there. And I think we all know ultraviolet light is this high energy stuff. This is the stuff that's going to give you a sunburn. If you go outside and spend too much time outside, the ultraviolet light is going to burn you because it's so high energy. The other thing I want to mention is that these colors here are what's called the visible spectrum. Why do you think it's called the visible spectrum?
So you can see them.
You can see them. What about ultraviolet? Can you see ultraviolet? No, we can't. I think there's some animals that can see in the ultraviolet range, but we can't. So this is the whole idea I'm trying to tell you guys. This is the stuff that we can see. This is the stuff that we can't see. But it's still light, but we can't see it. So if we can take ultraviolet light and turn it into visible light, well, then we're going to have some fun, right? But that's the whole basis of this talk. So what's happening in this guy, why this appears so bright, is there's 2 different types of light hitting it. So, well, actually, I guess I should use my laser pointer that I brought.
Oh, sure.
So this is my piece of paper. It's got some fluorescent molecules in there. And there's 2 different types of light hitting it. Well, okay, there's visible light. Well, okay, that's just typical reflection. This guy, the other guy, the loser in the battle of the brightness here, well, this is doing that too. It's absorbing visible light and it's emitting visible light. But the other light, the ultraviolet light, and even inside here underneath these fluorescent lights, there's a little bit of ultraviolet light inside there. The fluorescent molecule is taking this ultraviolet light and turning it into visible light. So literally what's happening is, in that orange paper, is it's emitting more visible light than it's absorbing. So that's why it appears so unnaturally bright. So we use this as an effect, as a commercial product, to create objects that are unusually bright. So what are some things? Anybody name something that's unusually bright? What? Yeah. Well, okay, that's different. That's not unusually bright. Well, got these guys, right? Do these look unusually bright? What else do I have? This guy. Does that look unusually bright? Well, I found that if something is unusually bright, typically It contains fluorescent molecules like highlighter pins. Okay, does that look unusually bright? It's written with highlighter pen. I'm going to prove this to you. So don't take my word for it. I'm going to prove to you in a minute these guys contain fluorescent molecules inside of them. We turn off the lights and we turn on the ultraviolet light. So this is the idea, is we use this whole idea of turning this very simple process, fluorescence, turning ultraviolet light into visible light as a commercial product. And there's one other place where it shows up. Hopefully, have you guys ever seen white shirts? So your shirt is going to glow here in just a minute pretty well. White shirts glow under ultraviolet, under my black light. You guys ever seen that?
Yes.
You ever wonder why? And
Yes.
it's not because it's cotton. Cotton does not glow under ultraviolet light. So let's take a look. I've got two samples here of cloth. So this is just cotton, right? What's the difference between the one on, I always get this backwards, because I'm reversed, on your guys' right versus on your guys' left? What's the difference? What?
Well, it looks yellowish.
Yeah! Which one would you want to wear? This one or this one? That one. Okay, this is for a good reason. You also notice, doesn't it appear really bright? Why do you think it's appearing bright? I'll give you one guess. Because it contains fluorescent molecules inside of it. So this is why. So this is a piece of cotton that doesn't have any fluorescent molecules in there, and it's actually really, really hard to find a piece of cotton without fluorescent molecules in there. I literally had to go around a fabric store with an ultraviolet light looking like a crazy person looking for this. It was hard, because if I don't put fluorescent molecules in there, white cloth appears kind of dingy color. And the idea is, everybody knows that they run cotton through a processing and then they bleach it. And they think that bleaching is what gets it this white. No, it does not. Bleaching only gets it this far. It gets it pretty white, but it's still got this dingy yellow color in there. So what they do is they put fluorescent molecules in there, and it does two things. It gets rid of this yellow color, and it also makes it appear very, very bright. Okay? So why we do this, and once again, I'm going to prove this to you in just a minute. Why it does this is if we look at this color wheel, and I always get in an argument with people over this, so just trust me, I've talked to artists about this, that we have a color wheel where the three primary colors, green, red, and blue, combine together to make white, kind of like what we were looking at with the white light earlier. Well, yellow is a combination of green and red. So if I can combine blue with it, yellow and blue actually makes white. So if I can put a molecule inside of there that emits blue light, that absorbs the ultraviolet light, and emits blue light, it gets rid of the yellow undertones and makes the clothing look white. So they actually, how they used to do this back in the day, I know this is kind of old school, but back in the olden times, they would give white clothing a little white bluing dye. They would dye white clothing blue to get rid of the yellow undertones. Other than that, over time, it will eventually get yellow. So another place where this shows up, and I think we all know this one, white paper. If we all use white paper in here, all right, you can see the difference. And once again, this one on this side is recycled paper that does not have the fluorescent molecules in there. This is the normal stuff that typically people use in printers. You can see it's got rid of the yellow undertones. It's kind of a bright color. There's fluorescent molecules in white paper. So when your mom told you not to eat paper, she was right. There's molecules in there that you don't want. Okay?
So this is where I get lost, is I'm going to add something blue to make it white. I'm just,
Exactly.
It's a logic screen.
Yes. So that's the idea, is there's yellow color coming from these things, from the paper and from your clothing. My fluorescent molecule is adding blue to the mix, because it's taking ultraviolet light, but you can't see it, it's emitting blue light. Yellow and blue make white. Alright? So I'm going to prove all this to you here in just a second. Ooh, it's time for a demo. Alright. So what I'm going to do, I'm going to turn on my ultraviolet lights. I'm going to prove to you these things that I've been telling you about. I'm a scientist, right? You don't take people's word for it. And so I'm going to tell you what my fourth grade teacher always told me. This is a small group, I don't expect this, but I'm turning out the lights. I expect everybody to act like adults. And to really have fun, we got to get rid of
Now,
this.
Tyler, I was giving him a hard time for wearing such a white shirt, but now we're going to be happy that he did.
So let's take a look. So hold up your light sticks. You see how they're glowing? I'm going to explain that in just a minute. See how it's working? You don't even need to crack them. I'm going to explain that in a little bit. But I don't want to get too far into that. But anything that's white, you can see the white coloring inside there. Okay? So let's take a look at some of the things I've been talking about. Okay? First of all, my fluorescent orange.
Whoa!
Look at that.
Whoa!
See, this is, I've been going to schools. You guys got to be able to have a room that gets dark. This does not have the stripes. So you can see it turns the
we got a
whole
room
room.
for you. You're coming. Gotcha.
It doesn't work so good if it's not so dark. But you can see it's literally lighting up the whole room because there's so much fluorescence inside. This is a really good piece of paper, right? Okay? So you can see that this guy's got some fluorescence.
And just to help me, I am a biology teacher,
Sure.
why is the other one black? Because
It's not, well, okay,
it looks black.
okay, I guess that's a good question. So this is actually a regular fluorescent light,
Okay.
and it's coated with what's called Wood's glass, which means that it is cutting out that whole visible portion of the spectrum, and it's only letting ultraviolet. So nobody's going to get hurt by this. And a little bit of blue comes through. So anything, so when I look at this, so this is my cloth, right? Look at that. So anything that's not fluorescent kind of appears kind of a dull purple color.
yeah.
A little bit of purple's coming through, but this is the same thing. So this is your white cloth that has the fluorescent molecule inside. Okay? We look at the paper, same thing. Oh, by the way, I mean, these things are only like 20 bucks. I've had more fun with these guys than anything else. Look at that, it's like enough. They put a lot inside white paper. I'm not gonna lie to you about that. So it's enough to light up this room. So, so what else have we got? So tennis balls, so this is another one. So they put fluorescent molecules in tennis balls to make it easier for your eye to see, right? I love this, is my favorite part. A lot of commercial products, so if you want to have a fun time, get a black light and go around your house. And I don't know why, I just love this. It looks like a little laser. This is something that I found in my wife's closet, so I appropriated it. But you can see, you know, a lot of commercial products have this guy in there. So you remember a highlighter pen? Look at that.
Yay!
So that is, you can see the highlighter pens are designed to fluoresce like that to give it a better look. And then this guy, I don't know why I love this one too. But you can go through, and I've actually, and you can look at it, that's part of why I get, you know, why it's fun to be a chemist. I get paid to do this. I get to go to toy stores and look for fluorescent things like this and show to you guys, okay? Before I continue on though, one last thing. So I told you that the white cloth does not have the fluorescent molecules in there. So how do you think we get fluorescent molecules into the white cloth? If I wash it, they're going to get washed away. And where do you think the fluorescent molecules are coming from? What? Detergent. Yeah. So if you look, so this is some Tide. This might be a little hard to see, but they put the fluorescent molecules inside of the Tide. And so every time you wash it, it gets inside there. So if you have dark clothing, it doesn't show up. It only really shows up when it's white. But the detergent has the fluorescent molecules. And so if you keep washing it, it will come back.
And it just provides a coating, and that coating doesn't come off in the dryer.
No. So it adheres. There's this actual chemical, not a chemical, but interaction between the molecules
Yeah.
inside of it. All right, so let's keep going.
I can't believe some activist group hasn't come up and banned that like it's a GMO type thing.
Yeah, so this is
Additive.
part of the reason why I do these talks is I realize there's a lot of weird chemistry in the world that nobody knows anything about. Trust me, there's way worse than this.